Hello, everyone. I am back with another video, and this time I am starting a new series called Math Matters. And this series is going to be one in which I discuss how the math that you learn in school or on your own is actually relevant and important in video games and software development. Because I think in a lot of cases, a lot of students feel like, why do I need to take math class? How is this going to benefit me in the real world? So I just thought it would be a good idea to share how, if you are interested in software development or game development, you actually do end up using a lot of the things that you learn. So let's get started. Today, we're going to be talking about our first topic, which is coordinate systems in games. So this involves positioning game objects on the screen. So let's go ahead and get started. So first of all, let's talk about what coordinate systems are. So you may remember this from probably like geometry or algebra, but coordinate system is basically, it's usually a grid-based system that uses numerical points to specify the position of locations on the grid. All right. And so you might also have seen something similar if you learned about how to read maps. Um, the most common grid-based system that you've probably encountered is the Cartesian coordinate system, which is what we're going to be focusing on in this particular presentation. But there are other systems that you might have heard about, such as the polar coordinate system, which is based on angles. But we're not going to be really talking about that this time. So with Cartesian systems, the positions are specified using XY pairs or coordinates, in which X usually specifies how far to the left or right a position is on the grid, while Y usually specifies how far up and down the position is on the grid, all right? And that's if you have two-dimensional coordinate system, okay? You could also have a three-dimensional coordinate system, which has a third coordinate value called Z, which usually represents how far a point projects, like out of the screen or paper. But we're not going to be focusing on that right now, okay? But just know that you can have 3D coordinate systems as well. Okay, so you've probably um, heard of this, and it'll probably ring a bell more if you actually see an image of it. So here's an example of a two-dimensional grid, two-dimensional Cartesian coordinate system. So some important terms and notes here. So the origin is the starting point of the grid, all right? It's usually marked as the point with the coordinate 0, 0. In the usual coordinate system that you've probably seen in math class, the origin is at the center of the graph, like you can see in this picture here. Okay. And by the way, if I use any pictures or images that I did not create, I've done my best to add a link to the image and the credit for it. So if you want that information or you want to download an image, I'll put that link in the comments or the description of the video. Okay. So again, um, the origin is in the center, is at 0, 0. We said that points are relative to how far away from the origin the point is. Okay. So we can see here we have a couple of different points that are on this graph. X, the x-axis is left and right. Okay. So as you move to the right, you can see that the coordinate numbers increase, right? So um, this purple point is the origin 0, 0. This green point here, 2, 3. So it's 2 steps away from the to the right of the origin. Okay. The y-axis is up and down. And in the usual Cartesian coordinate in math class, y the up direction is positive and the down direction is negative. Okay, so we've got the point 2, 3, just 2 steps away from to the right, and 3 steps up from the origin. And we've got on the kind of like opposite of that is negative 1.5, negative 2.5, which is 1.5 steps away to the left of the origin and 2.5 steps down. Okay, and you've got like this nice little grid, even with the evenly spaced numbers. Okay, like we said, points are coordinate pairs, usually in parentheses, with the first number representing the number on the x-axis, the distance on the x-axis, with the second number being the distance on the y-axis. Okay. Now, just for discussion's sake, like I said, we're not going to go too much into this, but if you have a 3D grid, it's the same principle as a 2D grid, but now you have a z-axis, right? So now you have, oh, well, in this case, the y-axis looks more like it's pointing out of the screen, while the z-axis is up and down. But the point is that you have 3 different um, numbers in the coordinate system for 3D. And like I said, you have to kind of imagine that one would be like coming out or into the paper or the screen. So you usually see this in 3D games. Um, and then if you have isometric games, which if you want to know more about what those are, I'll include a link here that you can look at in the description. Um, with an isometric game, it's like a 2D game that gives the illusion of like a sort of a 3D view by faking the additional axis. So, like I said, there's a link here that you can read more about isometric games, but we're not going to really focus on that right now. Okay, so these are the coordinates that you would really see, coordinate systems that you would probably see in math class that you might already be familiar with. Okay. Now let's talk about how this translates to computer or game screens. So when you're looking at a TV screen or your computer screen or your smartphone or whatever, you also have a coordinate system there. So when you run any software on those screens, the objects are also placed positioned on the coordinates, but it looks a little different from the Cartesian one that we looked at, right? So let's look quickly back at the 2D Cartesian coordinate system. We said that the origin is at the center, and we've got these quadrants where some of the numbers are negative, some of them positive, but they all go from the origin at the center. All right. So when you're looking at a computer screen, the main difference is that usually the origin is at the top left-hand corner of the screen. Okay, so that would be your 0, 0. Okay, and this image that we have here kind of simulates that. You see how the focus is really, you have that origin up here, but you don't really see those other quadrants that we had, those other areas where you had like the negative pairs, right? The focus is mainly on all of the points in like that positive direction, right? Um, so if you had a coordinate that was negative in, either a negative x or a negative y, it would kind of be like off of the screen. Okay. So that's the main difference, or one of the main differences. That's that on a computer or game screen, the general standard is that the origin is at the top left corner of the screen. Okay. There's another slight difference with the x axis. When you move to the right, that's still positive. Positive is still the right hand direction, and negative is still the left hand direction. But it changes on the y-axis. Usually that y-axis is positive as you move down, right? It gets bigger as you move down and smaller as you move up, which, as we saw, was different than the Cartesian coordinate system, where when you moved up, the y axis got positive, but got negative as you went down. Okay. Um, so you can think of your game screen or TV screen or whatever screen you're looking at as this modified coordinate system. So when we have objects, they're going to have like points or locations, but they're going to be on an axis that looks more like this. Okay. Now, when you choose your game development tools, like your game engines, you're using Unity or GDevelop or um, Unreal or whatever, programming language, make sure that you verify those directions, okay? Because I have run across some game development tools where the Y is positive in the up direction. So it kind of breaks that convention that we talked about for computer screens. So just make sure that you um, read the tutorials or documentation for whatever um, tool you're using. Okay. So what I want to do now is I just want to show you some quick examples on a computer screen in a game engine GDevelop. Okay, so um, let me change my share here. I'm going to share my GDevelop window. Okay, give me 1 second here while I get that up. And okay, all right. So this is just a quick example I put together um, where I have and let me put um, I'll put the grid on in a second, but I have a basic screen with a circle that represents the origin, um, and then two objects on the screen, a triangle and a square. Okay. And this is the GDevelop level editor where you're placing objects on the screen um, for your levels. And you can see that in GDevelop you can also add a grid. So that can also help you because that also shows the positions. Okay. So if I click on an object, you'll see like the X and the Y. All right, so those are the positions, right? You'll see that if I click on the circle, it actually shows you the position. So the circle here is at 0, 0. And that's again, my origin for the game screen, the top left hand corner. Okay. Um, and as I move down, my X for my triangle, uh, gets bigger because it's further to the right. And in this case, the Y, I've moved down from the origin, but the Y is positive. So the position of this is 421 for X and 321 for Y. And you could see that the square, it's further to the right. So the X is bigger, it's 847, and it's higher up. So the Y is smaller, it's 180. Okay. Um, and if I do a preview, which shows you like the actually makes the level playable, which you don't really have much playing going on here, but I just want to show you I can drag and you could see how the position changes, right? So as I move down, the Y gets bigger. As I move to the left, X gets smaller, right? If I move up, Y gets smaller. And if I move this, if I were able to move this off the screen, it would get big. You would start getting negative numbers for the Y. All right. Um, okay. And same thing for um, the square. Okay. Um, okay. So one thing, let me go back to the slides for just a minute here, because I want to make another point here. So one last point is about relative coordinate systems. So basically, so far we've discussed the coordinate grid system for the entire game screen or world. Okay, so there's one common origin for that screen, and all the objects on that screen are positioned relative to that origin, right? But you can also have individual objects um, that have their own relative coordinate system, right? And what we mean by that is that each object has its own origin. So when we're talking about each object has a position, you want to think about, well, uh, what part of the object is that position on, right? And that's what the origin would be. So as an analogy of in the real world, think about like you have a bulletin board, one of those boards where you can put pieces of paper on the board, and you usually attach it with like a push pin or a thumbtack or something like that. And the origin or the position of the paper would be where you put the thumbtack on the paper, right? So if we assume that each piece of paper that you have we use one push pin for each piece of paper. Where do you put that push pin? Do you stick it in the center of the paper on the bulletin board? In case if that's the case, if you put it in the center, then the origin for that um, paper would be the center. And we could say if we wanted to know the position, we would give the position of that pinpoint, right? Not the position of the entire paper. Or, do you put the pin on the top left? Where do you put it? So the origin determines where the starting point of the object is on the screen. Okay. So if you change an object's origin, it can also change the overall location of the shape or object. Okay. So let's look at that too here. Um, Let me go back to my GDevelop really quickly. And here's what I want to show you. So first of all, um, one thing I don't know if you noticed, when I moved my triangle up, okay, all the way up as far as I could go, I get a negative 30 for the Y, okay? So that means that part of it is off the screen, okay? But the bottom part is still on the screen. So where's the origin for this? Okay, because that means that the origin is off of the screen. Okay, so let's take a look. Let me show you in GDevelop. So in GDevelop, I can go to my, if I click on my, oops, no, that's not what I wanted to do. Sorry, I accidentally clicked the wrong thing. Um, okay, so if I click on an object, and I click on, there's an option here called Edit Points, and you can have different important points for your shapes. Okay, so you have an origin and you have a center. So the origin, if I click on the origin, it's this 0, 0, which is again the top left. All right. If I click on the center, or if I move to the center, that's the middle of the object, right? So I could change what my origin is. So let's look right now. Notice again that the origin point, the circle is entirely on the screen, okay? Because the origin for the circle is the top left corner of that circle, okay? So it starts drawing at the top left, and the whole object is inside the screen, okay? But look what happens. If I go to my origin, okay, and I go to my edit points, and instead of making the origin at 0, 0, let's say I make it the same as the center. Now the origin is at the center. The origin and the center are the same point. Okay, and I apply that. Look what happened. Now the origin, the reference point is at 0, 0 of the circle. And that center point starts drawing at the top left. All right. Now, if I preview that, now only that bottom corner, that bottom quadrant of the circle is in the screen. The rest of it is outside. okay? So that's why it's important that you know where the origin of your objects are, okay? Um, let's also try something different. Let's move the square and the triangle close to each other. Okay, so right now, they're not really colliding. They're like barely just touching, okay? But if I go and I change the origin of my square to the center, then that's going to shift the drawing point of my square, okay? So that's shifted. So it's shifted up a little bit, okay? So keep in mind that you do have the world origin system, which is for the whole screen. And then within each object has its own relative coordinate system. Okay, so that's all I wanted to share with you about coordinate systems today. And again, it's something that you probably learned a long time ago in math and didn't really see the value of it. But if you do anything with computer science and software engineering, this is an example where that math does matter. So thanks, and I hope you enjoyed this first edition of Math Matters. And stay tuned because we will have more.